I'm Kathy Dean from the university. And join me Professor Gao Chongwen, Professor Jiang Haifang, Professor Wen Xi, and Professor Xie Li. Now, the opponent should pick the problem to challenge the reporter. Have you get your challenge problem ready? Oh, introduce the teams. Okay. Today, the first role for the reporter will be Team Sci-Fi, and opponent will be Team Excelsior, and reviewer is小辣椒. So you can challenge the reporter your problem.
让他们自己自我介绍。
Okay, you should introduce.
先放松一点。
Okay.
Hello everyone, I'm the team captain of Team Excelsior 陈玉琪 and she is 孙嘉熙、叶俊怡、黄一涵和苏元全. Thank you.
I'm the captain and the captain of the Team Sci-Fi, and 我是陈义宇、周子宇、周丽宇跟徐来肉。
So, the team Excelsior, have you get your problem ready? Challenge problem.
We are going to challenge problem number 70, toxic reaction.
The report has several problems, so you have 5 minutes for preparation.
Chinese name, please. The Chinese one.
table of contents. And this is a problem statement. Wheel-master sticks can be joined together by slightly bending each of them, so they interlock in a carbon weave chain. And when you release one of its ends, it's gonna explode. So our theory is a dick bomb is a device constructed out of positive sticks woven together in a crisscross pattern. And elastic energy is stored in this deformation. If one of its ends is released, the sticks rapidly straighten out, releasing a net energy stored in their deformation. By removing one of its ends, all the potential energy stored at the second stage is released, and this energy is then converted to kinetic energy, and the stick jumps. And so it's going to be a propagates motion. And this is a video of our experiment. So for this experiment, we make a theoretical model. In order to study the behavior of a particle stick cobra, we develop our theoretical model by assuming that the particle sticks are rectangular rods and bend because of the construction of the bomb. Therefore, we can use the bend rod model for calculating the elastic energy of our sticks, like this formula. Where E, B, H, and L, and RC are respectively the Young modulus, the width, the thickness, and the length, and the radius of the curvature of sticks. We assume that the radius of curvature is the same for all the sticks. Yeah. So when one of its ends is released, the elastic energy of the sticks is converted to kinetic energy, and then this kinetic energy converted to gravitational potential energy. So we can assume UG equals to mgh, where this is the gravitational potential energy, where the mass of the sticks, G stands for the gravitational acceleration, and H is the height. So assuming that the motion is purely vertical, and that there are no losses due to the air or due to the collision with other sticks of the bomb. Every time a stick reaches a maximum height, we can assume it has no kinetic energy, only gravitational potential energy. So we can consider a bomb as a chain reaction and consider for each individual stick that all the elastic energy is converted to gravitational potential energy. So we can solve the equation UB equals to UE, which is like this one. UE equals to UG. By solving this equation, we can get the maximum height of each sticks. This is the formula we wrote. And on the other hand, there are some factors which are not included above, but might be significant. Previously, we assumed that the motion of individual sticks is purely vertical and that the sticks do not rotate, but in fact they do. So in order to have a more complete model, we include the rotational kinetic energy of the sticks where they reach their maximum height of the jump. So this is the rotational kinetic energy formula, where omega is the angular velocity of the sticks. And so we also have the angular velocity of sticks formula. By using the short movies of the explosion of a cobra, we measure the time a stick takes to fall to the ground from the maximum height, and the number of rotation it made during its fall. So we can calculate the angular velocity. So n is stand for the number of rotation, and delta t is the duration of the fall. We can get all this number from the videos. We found that the rotational kinetic energy is 2 orders of magnitude less than the elastic bending energy. which means we can actually neglect the angular velocity due to it's too small. So after we made the theoretical model, now we're going to start to do the actual experiment. We constructed 2 cobra of length into 3 meters. Each cobra was made of a different kind of obstacle sticks. The dimension of the sticks are shown in this table. For one cobra, we use the sticks which we refer to the larger one, and the other one we refer to the smaller one. The error for the dimension and the mass were given by the instrument used to measure them. So as you can see, the radius of curvature of the band was measured by taking some pictures of our construction. Thus, by using a photo editor, we fitted 5 circles to each different band stick, and the software informed us about the radii in the pixel. They were converted to meters as we had collaborated a known length on the photograph. Our result about the radii of curvature is also shown in the table, which is 0.3 meters for the larger sticks and 0.25 for the smaller sticks. After measuring the radius of curvature, now we're going to measure the yaw modulus. We assume the yaw modulus is their deformation is elastic because we place the positive stick at the edge of the horizontal surface, like this, and then the stick was fixed at the end with a heavy load. The other end was free to move vertically. Then weights of no mass were hanged on the free end, and as a result, the stick bent and we measured its deflection with the white ruler on the left. So by using this formula, we can calculate the yaw modulus, where W equals to mg are the known weights, and I is as previously stand for the second moment of the area of the cross-sectional area of the sticks, and then so on. So we can actually calculate the yaw modulus. So thus, by using all these numbers, we can predict the height. So by using this formula, we can actually calculate the height equals to 0.9 meters for the large sticks, and then 1.8 meters for the smaller sticks. And this is our prediction. Now we're going to do the actual results. In this experiment, so this is we calculate 0.9 for the smaller sticks and 1.8 for the larger sticks. In the real experiment, the experimental setup is shown on the slide. And to measure the height, we built a bomb on a big desk, and then we collaborated a ruler on the background. So we can actually measure the height. And this is the maximum height of the positive stick Cobra show. As you can see, our theoretical height is 0.9 for the larger one and 1.8 for the smaller one. But after we do the experiment, we can see it's 0.6 for the larger one and 1.3 for the smaller one. So we measure 20 different values of maximum height by using different frames of the video and calculate their mean average and their standard deviation value for the uncertainties. By constructing the theoretical height with the experimental one, for each popsicle cobra, we can calculate the relative error given by this formula. So after we calculate it, we can see the differences was 1.1 sigma for the larger sticks and 0.9 for the smaller sticks, which means our results are marginally consistent with the theoretical prediction. Because, and the fact that the theoretical value is larger than the experimental one, as you can see, it's a little bit larger than the experimental one. It's reasonable because we have not taken into account any of the losses that will lower the expected value. So in conclusion, in this experiment, we actually made a model for calculating the maximum height for each stakes. And then we realized the main parameters found to influence the jump height are Young modulus of the stakes, their dimensions, their radius of curvature, and when they are bent together, and also the gravitational acceleration. Thank you for listening. This is our report. And this is all the references. Thank you.
So, the opponent, do you have questions for the reporter?
And first, I want to ask that you mean the maximum height of the chain reaction, and what do you mean the maximum height? Is that each moment of the maximum height or the whole reaction maximum height?
It's the whole reaction.
Whole reaction. Okay. And I want to ask that where is the angular velocity in the reaction?
Angular velocity in the reaction. Oh. So by using this formula, after we take the videos, we can actually count how many rotations the stakes did. And then we can count the times started from the maximum height until it falls to the ground. And then.
And so you mean the number of the rotation, and I want to ask what is the number of the rotations? The n is the number.
The
I
value.
didn't get the
Which means like how many circles it did.
possible stakes,
Yeah.
each possible stakes, or
Yeah.
and I don't know how to say, but you said that the I is mean the cross-sectional area, and I don't know what the cross-sectional area means.
Okay. Okay. As you can see, I is a second moment of area of the cross-sectional area of the stick, which is like the area of the stick after you do a really like complicated math equations.
Okay, and next question. How did you get your number from the video? That
What kind of numbers?
the height of the experiment.
Oh yeah, I just said. No. Okay.
Maybe we can save the question for the discussion. So now we have 3 minutes for the opponent to prepare for the argument.
introduce about the particle chain reaction. And here's the problem statement. Wooden particle sticks can be joined together by sliding bending each of them, so they interlock in a so-called cobalt weight chain. When such a chain has one of these ends released, the stick gradually dislodges and will travel along the chain. Investigate the phenomenon. And here is my structure of solving problems. First, I want to know about what is the definition of the cobalt weight chain reaction. And next, I also want to know about why and how the energy converts to cause the chain reaction. Will the friction influence the effect reaction? And last question, how the relevant properties affect the result. And here is the reported outline. She gave us a clear video of her observation video, but I think her theory is too goofy to explain the phenomenon. And she also talked about the Young's modulus, and also in the experiment she gave us clear pictures, and in the project she also gave us the material of the stick, but I think she is lack of the parameters and also the lack of the relationship between the theory and the experiment. And her conclusion is see what her is different is in the maximum height, but I think she is lack of conclusion and experiment. And here is my point of discussion. First, I want to know about her theory. What is the definition of the Young's modulus? Because she mentioned, she talked about the Young's modulus in the experiment, and also will the friction influence the experiment. And next is the boundary condition. When you're forming a popsicle chain, the stick can form a popsicle stick, a popsicle chain. And next is will the cobalt wave have the boundary condition? And that is the experiment. I want to ask her about the definition of the wavefront, because in the problem statement lab, the problem statement mentioned about wavefront, but I think she didn't mention about it. And next is the main factor of this phenomenon. I want to really know about the phenomenon of it. And the third one is the rotation. In the video, the popsicle chain has its rotation, but I want to know why the popsicle chain reaction has this phenomenon. And the fourth is I want to ask the negative force, because in the reaction, I think there is some force will affect the result. And the 5 and 6, I want to ask the depth, thickness, and elasticity. How will it affect the experiment? And I want to skip to the next phase.
Okay. So now the floor is open for discussion. So we can answer your this question.
Okay.
Okay. So I want to ask, like, what is the definition of the Young's modulus?
Okay, so as we read the references, we can see it told me the Young modulus is actually E equals to the weight, and then times this one. And this is the formula we use. And actually, after we calculate it, we can see it's actually 7.1 GPa in this experiment.
In the popsicle sticks.
Yeah.
And what is the length and the thickness and the
It's in the table. This one. We have two kinds of popsicle sticks, which one is larger and one is value. And these are the length, width, thickness, and the mass.
And you mentioned that the 7 GPa is the popsicle stick, and is the larger one or the smaller one?
Oh, it's for both.
Both.
Yeah.
It's the
After
same.
we calculate, yeah, it's amazing.
Okay. And do you know what is the do you think the friction will influence the popsicle sticks,
Yes.
popsicle chain?
Yes, definitely.
And where is the friction in the popsicle chain reaction?
So I investigate, like at the beginning, I can see that when the beginning, when the state straighten out, actually there's an amount of energy is lost because when they hit the ground before they actually started jumping out, there's actually a friction between them and the table.
You mean the surface and the popsicle chain?
Yeah, before they started to jump up.
I disagree. I think that the surface and the popsicle chain, the friction of it can be ignored because I think its friction is it is so too small can it be ignored. And I also think that the friction between the popsicle sticks.
Yeah, I know. The friction between the table and the popsicle stick is too small to be ignored, and we can actually change on the different surface if we want to. But there's other friction, to be honest. Like after they jump out, they're permanently deformed, or if they wobble, or if they collide with different popsicle sticks. There's actually other
So you
friction.
mean the popsicle sticks between each other?
Yes,
Okay.
but the experiment is too hard to control. So we actually, and we don't have like those expensive, like the FPS camera to investigate the experiment.
Thank you. And next question, the boundary condition. I think, and I want to ask that when you are forming a chain, like you making the popsicle chain, do you think is there a boundary condition in it? It's like a limitation.
Limitation?
When you're forming a chain, do you think that is there, if you forming a chain and you can form actually a popsicle chain?
You mean like the difficulties I have?
Yes.
Yeah, they definitely have the difficulties. Like, it's actually really hard to form a chain by only one person. And at the beginning, I practiced a lot of times because they are really easy to explode.
Okay, but I think that when you form a chain, if the stick is, your module is too big, just like a stick is too hard or the stick is easy to break, I think it can form a chain. It's just like it's boundary condition. And when you if you want to release the popsicle chain, there is a boundary condition of the forming a crowbar ring. If you have the difficulties of the crowbar ring, forming a crowbar ring.
No, actually I haven't. I think those can be confined after you practice it.
And I disagree with the reported. I think that the gravitation is bigger than the stick to lift up its end of it. I think it can form a crowbar wave of it. And I want to ask about the experiment and what is the definition of the wavefront?
So actually there's two kinds of wave. So actually there's two kinds of wave. One is release the front end, and the second one is release from the end which you finish the cobra with. So like this one is the end of its end. Like
Who is the problem statement want to know about? What kind of wave?
we think it's this one. Like
Your reason?
reason? Because it says started from the front. And then this kind of wave is like we release the cobra weave from the front of the chain.
And okay. And I want to ask that what is the main factor of the phenomenon?
Main factor of the phenomenon?
Yeah. Like what caused this phenomenon?
Yeah, I think it's the elastic energy. Like when you form the cobra weave, you're actually bounding them together, and then you're like restrict them. So when you release it, they're like free. So they're like the elastic energy is out. So it's make a explosion.
So the elastic energy will explode, like change to the energy.
Yeah, it's gonna change to, like I just said, it's gonna change to the kinetic energy, and then change to the gravitational potential energy.
I agree with the reporter, and I think that elastic energy will change to the restitution force of the popsicle sticks, because the popsicle sticks they were bent, so it was not its normal position. So they want to return to their normal position. So when I resist for popsicle sticks, the other popsicle stick will have the space to expel. So I think it's what is called this phenomenon. And next, I want to ask how the rotation formed, and just like why cause the rotation at this phenomenon?
What caused the rotation?
Like, why do you think it will rotate?
We know this phenomenon from after we made a lot of experiments, and we didn't realize this kind of phenomenon at first, but after we start to track the trace, we realized that it's rotating, and it's amazes us.
So you didn't know why?
We still, I think it's because the energy is too big.
And in my opinion, I think that the particle chain, at the end of the particle chain reaction will rotate is because that the pressure which is given by the wave can hold the particle chain, so it will rotate. And yeah, and then I want to ask the magnetic force in the particle chain. Do you think that will the other force will influence the reaction? Like, can you think? Do you think about the other force will affect the result?
The only one force. There's too many causes can change the
Can you talk about
phenomenon.
some of them?
One of them is the friction, of course, and then the other one is the one I found is the rotating kinetic energy, because it's too small, so we left it.
Okay, I agree with the reporter that there is the friction will affect the result, and I also think that surface will affect the result too, because the surface will give the reaction, give the popsicle chain its force, because when the popsicle chain doing its reaction, the end of the popsicle chain will press the surface, so the surface will also give it a force. So I want to ask that, can you predict if the thickness, you have the larger thickness and the smaller thickness, and can you predict that the height of the thickness?
We actually try a lot of different kinds of popsicle sticks, like all the kinds we can find in the stores. But actually we tried the smallest one, but it's really hard to form a cobra with the smallest one. So I think you can make the experiment with,
Okay, thank you.
because you.
So, and when you do the experiment, are you using the same popsicle sticks, or you change it?
As I know, after you make one explosion, it's gonna make a permanent deformation, because it's bent already, so it's gonna change. So I need to change the new popsicle sticks for the
Okay.
experiment.
Now, your opponent can summarize the discussion.
And I asked about the reporter about the definition of the Young's modulus, and she said that it's the deformation about the solid material, and also she mentioned about the Young's modulus is about the measurement of the elasticity. And I also talked about friction of it, and she thinks that the friction of the surface and also the friction between the popsicle sticks also affect the result. But the friction between the surface and the popsicle chain is too small, can ignore. So the friction between the two popsicle can be influence result. And I asked her the main factor of the phenomenon, And I agree with the reporter that is the elasticity changing to kinetic energy and gravitational energy have this phenomenon happen. And I also have heard about the boundary condition, and I think that when you form a chain, if the stick is too hard or too soft to break, I think it can form a chain reaction, can form a particle chain. Thank you.
Now the reviewer, they're trying to think of a question
Okay, opponent, you have asked about the elastic fatigue. Would you think how will cause the elastic fatigue?
I think the height of the elastic fatigue will get lower. Also, the velocity of the particle chain will also get decreased.
For the reporter, the problem statement has mentioned the wavefront will travel around the chain. So why don't you consider the velocity of the chain?
The velocity of
The velocity of the chain.
because it's hard to track the velocity of the chain because there's so many possible states. So it's actually hard for us to calculate.
Okay. So please turn to your Young's modulus picture. Picture. As I know, the Young's modulus is about the expand and the press. Your experiment seems like you are measuring the shear modulus. So how could you show this is Young's modulus?
So we assume the Young's modulus is elastic because the weight didn't stay suspended for long and the determination was small. So we actually can use this kind of formula to calculate the Young modulus.
So opponent, how did you think of this is Young's modulus or others, like shear modulus?
What do you mean? Can you say it?
Yes, according to the Young's modulus definition, it is like to expand something or to press something. But according to her experiment with, it seems like shear modulus. How do you feel with that?
I think Young's modulus is the best, the best to test the elasticity, the material elasticity.
Okay, so reporter, how would you, because the opponent have mentioned that the surface friction will affect your experiment result. So how could you change the surface to make other different results?
As I say, the friction of the surface, it's hard to control it because
Excuse me, yes, I'm asked for what kind of the surface would you want to change to, yes, will affect the result?
if we
Time is up. So we just have 2 minutes for your presentation. So you can see the question. Reviewer, sorry.
Okay. Greeting everyone. I'm the reviewer of problem 17, toxical chain reaction. My name is Rin Liu. And this is my problem statement. I think the main point is a waveform travels along the chain. So, yes. So I think the velocity is an important factor that we should include it in. And this is an overview with the reporter. And in her observation included the video and the structure explained. And in her theory is the Young's modulus and the angular velocity model. And in her experiment as different kind of obstacle. In her conclusion, she mentioned the main parameter found to influence the maximum height is Young's modulus. Yes, this is the suggestion with the reporter. I think her strong point is she has quite detailed theory and relevant experiment. But I want to suggest the reporter is the phenomenon explanation is not detailed. And she has some misunderstood test movement. And this is pros and cons to the opponent. I think he has he has his own opinions presented. And I want to suggest the opponent he is not only about the discussion of the phenomenon. And this is a discussion between and the opponent asked the definition of Young's modulus. And the reporter showed her experiment picture and her formula to explain it. I think, yes, in my opinion, because the Young's modulus is to expand the material or to press something. So I think it's just like shear modulus and not Young's modulus. And the opponent asked for the main factor of the elastic energy. And the reporter thinks the main factor is the potential elastic energy. But I think the reporter should include the rotation energy and the air resistance force because the obstacle stick is too light, so it may easy to be affected by the air resistance. And the opponent asked for what does cause the rotation. The reporter is still annoyed. Yes, and yes, because the rotation is very complex. So I think we can discuss it later. In our discussion process, reporter kept looking at her script. I think it's not bring the script on the stage is better for them. Yes, thanks for your attention.
So I want to say something about the reviewer said we have mislead the test. We actually calculate the energy first, and then we calculate the maximum height. And I think the main point of this experiment is because the energy the particle have. So I don't think we have mislead the test. But I also think the reviewer is very careful in listening to our report and gave some really good suggestion, and we're gonna keep in mind. Thank you. And then I think the opponent does not understand the true meaning of the Young modulus. The Young modulus is related to the change of the original length of the chain and the force on it. Also, a lot of the opponents' questions are about the facts we already started in our presentation. And he insists that he's disagree with our experiment but never prove it. So I think, and actually our main point of this work is to look deeper in a traveling wave, and we actually examine with parameters affect the height and the wave and how it affects it. And we also investigate the physics of band materials and derive the potential energy around which we base on a theoretical mode. So, and we also present the results of the experiment that we perform, which refer to the Young modulus, the geometry of the stakes, and the maximum height of the jump after the explosion. And we also compare the results with our theoretical calculation. And the theoretical calculation is actually quite approximately to the actual height. So, and I think this is our presentation. Thank you.
Now it's time for Joey's question. Okay. Professor
Can I
Chen.
see the video again? How fast is your video?
200 frames.
200 frames. Could you repeat again? Okay. Did you see that the maximum height is going to increase to the last end?
Yeah.
Could you explain why the beginning, the height is not reach the highest, but later it will reach the highest?
Because at the end, the positive stakes, there's only a little left of the positive stakes chain, and the energy is getting increased, and then the energy is too big, so it's gonna
Okay.
do a really big hoop.
Have you ever tried to measure the moving velocity of the front end?
I don't know what you mean.
Okay.
Sorry.
Because it's moving, right?
Yeah.
The whole front end is moving. Yeah. Have you measured the velocity?
Oh, amazing. Actually not, because there's too many particle stakes, and it's actually hard for us to calculate the velocity.
Any more questions? Okay, Professor Chen.
Since no people will ask, I will ask. In your equation, you actually give the elastic energy and the gravitational energy and what else? Rotational energy. It's all referred to single stick, right? But however, when you watch the video, you see there is an interference between the other stick, right?
Yes.
Have you ever considered that? Have you ever considered that? What's the effect on that?
Effect of the rotation. I think when the particle sticks combine together, and I think here's the friction of it, and it's the.
Is that the friction or just that somebody is pushing it down?
Oh, I think if the wave is traveling along the chain, the wave will go up. But I think there's another force is pulling down in front of the wave. And but
What's that force?
I think it's the reflex force.
Okay, never mind. But how about you? You mentioned the wave. You are the first one mentioned the wave. Okay. No, actually they first. But you mentioned the wave is the most important. Why?
Why the wave is the most important
in this question. Why?
Your question is why cause the stick fall down?
And we can sometimes. So we will show our point to the teams. So first for the recording. 6, 7, and 6. And now for the point for the opponent. 7, 6, 7, 8, 8. Okay, now the point for the viewers. 8, 6, 5, 6. Sorry. 8, 6, 6, 6, 8. We have 10 minutes break. Let's start from 2. So the opponent, do you have your challenge problem for the reporter?
Yes, I want to challenge the aerosol number 2.
Problem number 2. Aerosol. Still having one. Oh, okay. So we should call him back. But now you say can we okay, it's back. Okay, they reject. Do you have a second question? Second problem?
Sci-Fi sound. Sci-Fi sound.
Sci-fi sound. Science fiction sound. Oh, okay. Science fiction sound. Sci-fi sound. Science fiction sound. Sci-Fi sound, right? The
Spring.
spring sound, spring one, right? What's the problem number?
Really just because we change our mind. We are so sorry.
Oh, you want to change it to another problem?
Sorry.
Okay, what's your challenge problem? You accept or reject? They accept. So you have to stick with it. Okay? There's some dispute. They want to change their mind, but they have already accepted the problem. Okay? No problem? No problem. Okay. So the reporter has 5 minutes for deliberation. It's a spring problem, This one. Reporter, please start the presentation.
Honorable jury and fellow debaters. Today I'm going to report problem number 8, Sci-Fi sound. I'm a reporter from Team Excelsior. This is the problem statement. Having a helical spring can make a sound like a laser shot in the science fiction movie. Investigate and explain this phenomenon. In this problem, we will mainly focus at why will this happen, why will sci-fi sound happen, and second, what is the main cause of sci-fi sound. This is my report outline. First, I will show my observation video to you and how I observe and analyze all the data and the sound. Third is the setup and equipments for all of my following experiments. Fourth, I will show my experiments to you and their results. At last, I will show you my conclusion of all the experiments.
Oh.
This is sci-fi sound, and this picture shows how we knock the spring. And the angle protractor is for us to analyze the angle. So the force that we hit the spring will be the same. This is how I observe it. First, I use Audacity to record the sound, and I change it into spectrogram so that we can analyze it. And then this is the picture from tracker. You can see it's not clear, but there are some black dots, several black dots over here, and this is where our data comes from. Then we put our data into Excel, and then we will get this graph up here. This graph is to help us to observe the decrease of the frequency. And this chart is when we put all the data into the equation, into our equation, then we will get this chart. And in the following experiments, I use this chart to see that if my experiment is related to the theory or not. This is my theory. When a force hits the spring, it will cause the spring to have a deformation. And this picture is to show the deformation. The deformation will cause the tension of the spring to be different. And according to this formula, we can see that if the tension of the spring increases, the speed of wave will also increase because the density of the spring is always the same. And let's look at this equation. I think the wavelength of the spring will remain the same because we use the same material. And when the wavelengths do not change, according to this, the speed of wave will increase, and then the frequency will also increase. This theory is we got this from this paper over here, and according to the paper, we can see it said that this equation is related to Bernoulli beam theory, which is this picture shows, and sigma 0 and sigma 1 over here. We consider it as when the wave travels inside the spring, and it is the wave that is absorbed by the spring. And if we ignore it in our experiment, then this part of the formula will equals to 0. Then we just have to look at the equation over here. And also according to this paper, we can get the equation right here. After some calculation, the paper told us that the former equation that I mentioned equals to this one. And for this one, we can see that the frequency will decrease with the function of time. And the time will change. The time is positive correlated to this value. And in the following experiments, I will use this one to analyze my data just like what I showed before. these are my experiment equipments. These are my springs, and these 5 are metal springs. The diameter are different, and these 2 colorful ones, they are made of plastic. And this is the simple pendulum that I use to knock the spring. And this is the microphone we use to record the sound of the spring. And this is the string we use for the simple pendulum, and we connect the spring with the so that it will not shake a lot. This is our experiment setup. I put the spring vertically, and this is how it looks like. I knock the spring at the top of it, and I record it at the bottom of it. The microphone is connected to the computer, so that I can use Audacity to record the sound. And this is how it looked like in our experiment. Before all the experiments, I want to talk about the definition of sci-fi sound. I define it as the frequency will change during with the function of time, and the highest frequency will appear at first, and the lowest frequency will appear later, at last. Because of and this sci-fi sound must be caused by the tension inside the spring. These are my experiment parameters. First, I will compare plastic spring to metal spring, and then I'll change the length of the spring. And this experiment, I use metal spring and plastic spring. Fourth, I will show I change where I knock the spring. And the last one, I will change the material that I use to knock the spring. This is the first experiment. I compare plastic spring to metal spring, and I control the length of the spring to be the same. From this chart, we can see that the highest frequency of plastic is much more lower than the metal one. If we observe it as at the time equals to 0 over here, you can find that the dot did not pass the 0. I think it is because the frequency that we can record is limited. The highest frequency that we can record is about 8,000 Hertz. And I believe there might be a higher frequency that can make the data make this value to reach 0. This is the second experiment. I changed the length of the spring, and this time I used metal spring to do this experiment. This is the result that we got, and the reason why I connect all the dots together is because it is easier for us to observe the difference of each spring. And from this chart, we can see that when the total length gets longer, the frequency will decrease slower. And I think it is because when two things with different velocity when it just travels for about 9 centimeters, and you cannot see the difference of them. But if they travel for 900 centimeters or much more further than that, then you can see the difference obviously. And this is this chart is about when we put all the data into the equation. And this time we use plastic spring to do the same experiment. This is the result that we got. It is similar to the metal one, but as you can see, the highest frequency is different. The highest frequency of metal spring is about 7,000 to 8,000, and the highest frequency of plastic spring is about 1,000. And also this is, we put our data into the equation. This time I changed the knock position, which is L2. L2 is the distance between the knock position and the microphone. Then from this chart, you can see that the dots, they are nearby each other, so we define it as knock position will not affect this phenomenon. The last one is the material that I use to knock the spring. I use glass, plastic, rubber, and metal to knock the spring. It is the elastic coefficient of them, and I observed from the experiment when the elastic coefficient increases, the frequency will also increase. And this is what I observed. I think it is because if the elastic coefficient decreases, like the rubber, it will absorb more force that it gives to the spring. So that the frequency will be lower because the force that it gave the spring was lower, so the tension will be lower. This is my conclusion about the theory part. I define Sci-Fi sound as the frequency decrease with the function of time, and it must be caused by the different tension because of the deformation inside the spring. And the higher the frequency is, the faster it travels. And this is the formula. I show it again. And this is the conclusion about the experiments. When the total length decreases, the frequency the decrease of frequency will be obvious. And when the frequency of metal spring is high, will be much more higher than the plastic spring. The knock position will not affect the phenomenon. And the most important parameter that I think is the total length. Thank you.
Now, it's time for the opponent to ask questions on the previous session.
Okay, you can use page 4. And the spring motion just one direction, motion. Just up and down or left and right or both.
I consider it as when the load hit the spring and the wave is inside the spring. So I think that how does the spring, will it hang left or right or up and down, it will not affect the phenomenon.
Turn to the page 8. And so you use the equation to explain how the sound will form.
I use this phenomenon to show that if it has a deformation on the spring and it will form a wave, and this is the wave equation inside the spring.
And could you turn to the page of density? So the unit of the first picture is frequency.
This is frequency and this is time.
And in a trigger also is frequency and time.
Yes, it is.
Okay, now your opponent has 3 minutes to prepare for your speech.
I'm the opponent for problem number 8, semi-song, and I'm from team 我是小辣椒. And this is the problem statement. I think the main point is the laser shot. And this is the outline of the reporter. And she mentioned the structure and equation of reference and different material and lengths of do experiment of different material of length of spring and knot position and knot, and the conclusion is knot position downward effect phenomena. And the strong of the report is illustration of her setup, and I have some suggestion for the report is the lack of the explanation of the data and insufficient analysis, and partially fulfill the investigation. And I want to add some problem about the device and the definition, because I want to know the force, how should we control the force to the spring, because if the force is not fixed, maybe it will affect the sound of the spring. And the second is the definition of the laser shot, because the problem statement mentioned that, and I want to know how she definition the laser shot, because that could exactly know if they do what problem statement want. And the question of experiment, the first is the motion of the spring. Does the motion of the spring have relation to the semi-sound? And I have asked the report. And second is the wave, could the report know the wave speed when the semi-sound form? Because I think the speed may affect the semi-sound, that may difficult to form or not. And the meaning, because some color of white showed in her spectrum, I want to know the meaning of that color is what. And let's into discussion. And could you turn to page 9? So the T means the time, and what time will affect the sound?
Because the frequency will decrease with the function of time. When the time goes, the frequency will decrease. So it is related.
And you mentioned that you define the semi-sound as the frequency will decrease over time, right?
Yes.
And so you mean if the frequency is decreased and over time, no matter the time interval is long or big, is long or short, will also form the semi-sound.
The Sci-Fi sound is formed in a very short time, as I showed in my graph. You can see that this is second, and the Sci-Fi sound will form in a very short time.
Okay, and could you measure the speed of your spring?
Measure the
Speed of your spring, right?
speed of the wave.
Yeah.
The speed of the wave, because I think they're, as I mentioned before, the higher the frequency is, the faster it will travel. So I didn't measure it.
Okay, and when you recorded the sound, would it exist the background noise?
I try to keep the background quiet, but I think a little bit noise would not affect this phenomenon because the sound that we record is, it has a very high frequency.
And in a quiet, identity will affect the sound. Density,
Density is, I just use the same spring in one experiment so that the density would not change.
So didn't change the density of your
I use metal,
and
all of the metal spring are made of the same metal.
and so when the microphone records the sound, will it attach to the spring?
Would it attach the spring? I put it in the bottom of the spring. Yes, it might touch because the spring will shake a little.
And on the top of your spring, you connect a bolt, right?
Yes.
So the sound different when connect on a bolt or under the spring. Will it different?
What do you mean under?
The sound when the sound connect the bolt and the sound under the spring when the spring is vibrating.
You mean when I knock the spring at the bottom of it? Do you mean that?
The top and the bottom, the sound of the top and bottom will it different?
You mean
Because you connect a bolt on top and
yes.
under the spring.
The reason why that I didn't record it at the top of the spring is because when the load knocks the spring, it will have a sound that when it hit the spring, and we don't want that sound. So I recorded it at the bottom of the spring.
Could you turn to the current one? And the plastic and the graph of the plastic and the spring.
This one?
Yeah. And why the plastic was lower than the metal?
The reason why the plastic it is I mentioned at the last graph of my presentation, and I said that I think it is because of the there are two materials. They are different, and when the materials are different, when I knock the two string with the same force, it will not the tension inside the spring will not be the same, so the frequency will not be the same.
And when you knock the spring, the sound in the spring have a lot of different frequency.
A lot of different frequency. I think there are when I knock the spring once, there are not just one wave that formed. So all the waves that it formed, it have different frequency.
And could you exactly define the show time? You said a frequency decrease in very short time, and could you exactly define the short time is the range of the short time?
The range of the short time. I think it is it is shorter than 0.1 second.
So if the frequency decrease in 0.1, which means every not just spring and other thing can also introduce the sound.
I think if you have a string that is long enough and you have the a microphone that can record a small sound, that a very long metal spring can also form Sci-Fi sound.
So only spring can form the Sci-Fi sound, or another thing can form Sci-Fi sound.
According to the problem statement, and it just asks us to use the spring to measure it.
And the temperature affect your sound.
The temperature affects the sound. Because the sound didn't that we measured, they didn't go through the air, so I don't think the temperature will affect a lot.
But the sound just move on the screen that goes through the air.
It might go through the air, but the sound that we want to measure is the sound inside the spring. It travels through the spring every turn.
But the vibration will cause the sound, and which means that you can record the sound, and the sound is big enough. The vibration is very big, so the sound is big. You can record. Then the string move. There's a lot of range.
The spring
The string move is very.
you mean that will the spring shake a lot?
Yeah.
I think that because that we use a single pendulum to knock it, so that it will not shake a lot. It will just shake a little, because the simple pendulum is not very heavy.
And not shake very a lot, so why the sound is big to hear.
Why the sound is
Because the sound only the Sci-Fi sound only on the spring, and if the spring didn't vibration a lot, and
the vibration that we want to measure is on the spring, but not how the spring shape, how the whole spring shape. It is about the tension on the spring.
and you put a microphone under the spring, and would it record the sound in the air?
Yes, we might record it, but I think that the highest frequency and how it decreases, it is not the sound that goes through the air.
And if the spring didn't connect the ball, would it also introduce the Sci-Fi sound?
Didn't connect the ball.
Only the spring and the spring vibration would it introduce the Sci-Fi sound?
You mean if we do not knock the
Connect anything, and just the spring.
Okay, now we should stop here, so we can continue the discussion later. So we have 1 minute to summarize the discussion.
Report didn't measure speed, and I think it is important because if the speed is different and the sound might be affected, and a report say the density not changed, but she didn't measure that, so she couldn't sure the density is fixed or not, and the sound on the top and the bottom both can be recorded because top sound is important, and because I think if you connect both the sound connect both my louder than the button, the sound of the button. Thank you.
Now the reviewer is
And I have some questions to the reporter. And in your presentation, you only consider the tension of the spring, right?
Only consider the tension.
The force effect on the spring, you only consider the tension. And have you ever tried to consider that the stiffness of the beam and of the material?
Yes. Because of the different thickness or how hard the material is, and the deformation that I cause on the spring will be different.
Can you turn to the page now? And so, like in your explanation, you set the higher frequency, and you set the times, and will affect the frequency, and we will form the feature.
And it's not the time will affect the frequency; is the frequency will decrease with the function of time.
And okay, then can you explain why we'll have this effect?
The frequency was affected by the deformation, and so it will cause different tension on the spring will form like this that I showed before. So the different tension will cause a different frequency wave, some different frequency waves.
So you say that and we will form some the different frequency waves, and why? And you didn't explain why will the frequency will pass through the spring in the same velocity. And
It passes through the spring with different velocity, and the higher the frequency is, and the higher the velocity will be.
And I want to ask some question to the opponent. And you have mentioned a lot of the parameters on the spring. So I want to ask you which parameters that will influence the experiment the most.
I think the density of the spring will affect the sound a lot because when it's different material might cause the sound different.
And I want to change some question. And my question I want to ask is what parameter will affect the scientific sound the most? Not will affect the other parameters. Other result, I want to ask what the parameter will affect the scientific sound from a lot.
I still think it's density because the density will influence the sound a lot, I think.
Okay, let's stop the discussion and review the time to prepare Now the reviewer is
So after this we will and let's take a look about the problem statement first. And the problem statement says that tapping a helical spring can make a sound like a laser shot in the science fiction movies. And investigate this phenomenon and explain and explain the phenomenon. And first we want to talk about the reporter's presentation. And in this presentation, our position and the report support is you can understand the phenomenon and you can use the detector data and video to analyze the phenomenon. And the theory and we see that they are trying to use some equation to explain the phenomenon. And we think that it didn't consider some like the stiffness in the spring and maybe the stiffness will affect the model. And the Senna and Nicholas a very good experience to the experiment. So that we use and their experiment they use a very many different variables. But I think that the problem is that they didn't explain why they want to choose these variables to do this experiment. And the conclusion that they use the result to explain the phenomenon very clearly. But I think that they should try to compare all the parameters and into one equation or something like that. And when the proposal report and in the discussion that the proposal can answer the opponent question patiently. But we think that the quarter counts is no further scientific explanation. And we think that the opponent's problem is it didn't maybe it did not mention the presentation and I think that they ask too much problem to the experiment. And we want to discuss and the opponent asks the reporter that why would the time affect the frequency? And according to the reporter's answer that the time has a positive relationship with the frequency or that was a something relationship between the time and the frequency. But as I know, I think that the frequency is because in this spring and if I tap it here and it will send an impulse to the spring, and because the spring will have a vibration and in a tension and stiffness, and we will cross the subway decrease, and the higher frequency can go faster, and the lower frequency will go slower. So I think that is the main effect the cyclic sound. And next question is about I want to talk about one more thing is that the spring that they only consider the tension, but I think that we should consider more force in this and this spring and have the curvature and temperature the coordinate of the curvature and its own things, and we think that it should consider the tension and stiffness, and we can get a very close and we can get a better model. Thank you.
This is my concluding remark. As the opponent asked before, and I said, the motion of the spring, which is up and down or left or right, will not affect this phenomenon. And the definition of sci-fi sound is the frequency will decrease with the time, and it is caused by the tension on the spring. The speed of the wave, according to my report, the higher the frequency is, the faster it will travel. It will travel through the spring. And I have considered about the background noise, but I have tried to reduce it, and it was so little that it won't affect. When I change the different material of the spring, and it will cause different tension on the spring because the force that I give the spring will be absorbed by the material. And the temperature that the opponent and reviewer had mentioned before, it will not affect a lot because the sound is traveling inside the spring, and that is what my report is talking about. And I have to say that according to my theory, the most important thing that I think is the most important parameter that I think is the length of the spring. So I do it twice of the metal spring and the plastics one. So I think it is the most important thing that affects this phenomenon. And
Now we have time for Julie's question.
Can I see your conclusion again? So different material knocking on the spring will cause the different frequency, right?
yes.
Knocking position won't affect the effect. Means,
And this
can you try different position?
different position, and that is the different position that I knock the spring, but I put the microphone in the same place.
Okay.
I changed where I knock the spring.
The most important thing is total length. Why?
This is the most important parameter because I think and this is how we measure, this parameter can help us to know that different frequency will cause different velocity of the wave.
Okay. Let's go back to the spectrum. The first one, you will show the spectrum that have the different, at different time, it will show the different spectrum. Yes, that's right. Have you ever tried to measure the peak, the first peak? What's the spectrum of that peak? You just measure the highest frequency, right?
I measure this whole line.
This whole line means it's a distribution.
Yes. I measure the whole line of the I measure the whole first line.
Why there is the second spectrum?
I think it is because of the echo, and it means when the wave transfer from the top of the spring to the bottom, and it will go back again. And yes.
You say it. You say it. Okay. Let me ask you a question. Have you? Okay.
Okay, just one principal question. So, for the sound, for the signal, for a short time,
Yes.
how do you decide its frequency? I'm puzzled. How do you decide? Yeah, obviously the sound just appear for a very short time, right?
Yes.
So how do you decide its frequency? What does the frequency mean?
The frequency means the frequency. Because I think the amplitude was just the amplitude just means the
Actually, if the wave with a single frequency, it will
I think-
continue forever. So you have to do the analysis of your frequency. You definitely have very many waves. So you should have many frequencies.
This is frequency, so there are many waves that cause the frequency to decrease.
Do we have more questions from Shu?
I have a question for opponent. Okay, you kept asking question about the air. So what's your opinion on the effect of the air?
I think the sound in the air is one of the Sci-Fi sound.
So you said you has to be considered.
Yeah.
Okay. So what's your opinion in real?
And I think that when we hit the spring and you have the vibration on the spring, and the Sci-Fi sound is because of the spring, it's not because of the air. And I think that we have an impulse in the spring, and because of its material or some in this medium, and we think that the one single impulse will express into different frequency.
Thank you.
Seven, 5, 8, 8. Seven, 5, 6, 6.
Give me the time. I have the trouble.
Six. Eight, 7, 7. Hold on, it's away. Eight. Okay, shall we take 10-minute break? The opponent, do you have a first problem for the reporter?
I would like to challenge problem 1, invent yourself.
Problem 1. And then there's okay, the reporter accept the challenge.
increase the result.
everyone, I'm the reporter. I'm the reporter from 听我是小辣椒, and today I'm going to report to you the problem of number 1, imagine yourself. And this is a problem statement. I think the theory, corona charge, and design the motor to reach a maximum speed is the point of the problem statement. And this is my outline, and this is my equipment, and the charge resource is from the generator, and when the razor A is connected to the generator, and the razor B is connected to the variable resistance and the ground. And this is my video, and I used the slow motion to take this video. And this is a video of commodity charge, and you will see a flash in the video, but because the video couldn't be played, so it should be have a flash, and that we know how the periodic charge exists. And when the periodic charge exists, the light will have a flash. And this is my theory. First is periodic charge, and the second is Coulom's law, and the third is rotary inertia. And the theory of periodic charge, this is razor A, and this is a pen. I patted the razor to the pen and let the pen fix on a surface, and when the razor gets the positive electrician from the generator, and it will fall off the positive electrician, and because the razor is very sharp, so it will cause the air into the positive charge and the negative charge, and then the negative charge will be attracted by the razor, and the positive charge will be repelled by the razor and make the aluminum foil full of positive charge. And because the razor keep getting the positive charge from the generator, so although the razor get a negative charge from the air, it still keep positive, and the aluminum foil also keep positive, so the razor will repel the aluminum and make the rotor spin. And on the other side of grounding, because the razor of grounding will get some negative charge from the ground, so it will fall off the negative charge, and then when the aluminum foil, it will also make the air into positive charge and negative charge, and then the same process. So the difference is foils will become to medium, and then the rotor will keep spin, and the foil will get a positive charge and just keep this process. And the second theory is Coulom's law, and I define the K is constant, and Q is the load of charge the aluminum have, and second is, and Q prime is rather A or rather B, when depends on I choose which part to calculate, and the R is between the razor and the foil. And sorry, this is a rotary inertia, and I define the alpha is angular acceleration of the rotor, and R is the radius of the rotor. And this is my parameter. First is number of aluminum foil. I will change the pieces of aluminum foil. And second is angle, and third is resistance of grounding. And the the result is angular velocity, and this is the number of foil. You can see that. Sorry, this is wrong, and it should be 2 pieces and 3 pieces and 4 pieces, and the line should be the fewer pieces, the angular velocity will be faster, and I divide the angle by I only change this distance of I fix this system in 2.5 centimeter, and I only change this distance and cause the theta change, and in this chart should be the more degree will the angular velocity will fast. And this is a resistance, and you can see that the resistance bigger, the velocity will be bigger. And this is my conclusion. Because the lot of charge, because in the first parameter, the different pieces will have different, because I fixed the total area of aluminum foils and I cut it into different pieces, and so each area of aluminum foil is different, and so that the load of charge will be changed, and that causes the force different, and let the velocity fast. And the second, because the angle is bigger, it will not just, the charge will just go through the center of the rotor, and it will make the angular velocity faster. And the third is the bigger grounding resistance is the speed will be bigger, because if the charge keep on the rotor, it will make the rotor hard to spin. And if the grounding resistance is bigger, the charge will lose the fuel, and the charge will so that the velocity will be faster. And thank you for your attention.
Now, your next question regarding the presentation.
So can you turn back to where to talk about how to design your sphere? Yes, parameters, please. What do you mean? What is the angle should be meaning?
This is the angle.
You mean that is your electrode, the line right there with the small dot?
The razor and
Well, that is the razor and this is the rotor.
yes.
Okay, thank you. And can you turn back to the parameter again? So what do you mean by the resistant grounding?
I use the variable resistance resistor to change the resistance of bonding. Because when I bonding, if I change the resistance, it will make the bonding side, the system of bonding side will change. The system in the bonding side will change. So that's.
So you mean resistance, the electric resistance, right? Like if you put more resistance on a grounding line, then that means less electrons will be coming into the grounding wire. Is that what you're meaning about the resistance of grounding?
Yes.
Okay. Then can you turn to the chart? Any chart. Okay. Can you explain why there's negative numbers?
Oh, because the spin is have a different direction and in direction. And
Oh, you mean turns backwards is negative number, turns
Yeah.
forwards
Yes.
positive number. Okay, thank you.
Now, the opponent can prepare for the implementation. The opponent please take the floor.
So here I represent Team Simon as the opponent. And the reporter's outline for their introduction about, I noticed that they built a Mandigraph generator, which is, I saw it on a YouTube video and it's pretty hard to build. And this is a pretty notable part about their experiments, and it's pretty nice for them to build such a generator. And another thing is that I noticed that they didn't mention the ionic wind, which is the theoretic background that makes this rotor moves. And I'll explain it later. And theoretical, I think, yeah, it's nice for them to use many axioms, because in our experiment we only use 2, but they use like 3. But I think that can be clearer in explaining how the motor works, because how they, like the report talks and a little bit on and off, and I cannot get their points. And about their experiment and conclusion, and their parameters based on their theory. That's a good part about their experiments. But what they did on their bar is wrong, and they don't have an equation to support their results. And can I get into discussion or?
Okay.
Yeah.
Going to the discussion here.
So the first question I would like to ask is, how did you measure the angular velocity of your rotor?
And I use track to trace the red dot and it will show the angle, and I use the angle to calculate the angular velocity.
Oh, because you didn't play the video, so I didn't know how to make it. Okay.
So it just keep it spin.
Okay. So the second question is about, can you explain the relation between your experiments and rotational inertia?
Because the velocity is because the acceleration will different, and and it would affect in the first experiment, because the mass of each rotor is quite different, so I use it to explain the first parameter, the number of coils.
Okay. What do you think is the main force that is making this rotor spin?
I think the force, the razor will repel the
You mean the
coil,
Coulomb
and
repulsion?
yes.
Coulomb repulsion.
Yes.
Okay. So, did you read about a paper that is talking about ionic wind? Because what I have done in my experiments is that I found that there's two kind of variables that will affect how this rotor moves. One is the Coulomb velocity, that is the same electrodes, they will push each other, and the different electrodes, they will attract each other. And so, because my motor is different from yours, and I think yours, your motor will also form a ionic wind, which is when which razor is connected to the vanguard generator, razor 1 or razor 2.
Both razor 1 and razor 2, but the razor 1 is affected a lot than the razor 2. The razor, the grounding side.
Which one's on grounding side?
The razor 2. Sorry.
So the razor 2 is connected to ground?
Yeah.
Okay, so razor 1, theoretically they will that's razor 1, will produce a very high electric field, and thus it will ionize the air around it. And because the air molecules around that razor will also be charged with electrodes that is with razor 1, it becomes either positive or negative. So is the razor 1 a positive electrode or negative electrode? Like in electricity, we have two kinds of electrodes. One's positive, one's negative. So do you know what kind of electrode is connected to razor 1?
Positive. We use a sensor to measure the generator and shows it's positive.
Positive. Okay. So that means if razor 1 is connected to positive electrode, then the air molecules around razor 1 will be ionized because razor 1 will create a very high electric field, and these collide with the air molecules around them, and so the air molecules will become positively charged and be repelled by Coulomb repulsion and onto the rotor. And so because the rotor also becomes positively charged, and razor 1 also positively charged, and because of the Coulomb's law, both of them they're with the same electrode and they will push each other, so the rotor will roll, right?
Yeah.
And do you mean that's when you roll to the other side, razor 2, and because razor 2 is connected to ground,
Yeah.
so it put the electrons back onto the rotor, so it become neutralized, and because razor 1 is still pushing the rotor, so the rotor just rolls to the other side, and the neutralized foil will be positively charged again on the razor 1 side.
There's a lot of foil, and when this side have a foil and this side also have a foil, so we just separate two.
Yeah, I know. And also another point is that why do you think the numbers of aluminum foils will affect how the rotor rolls?
Because if you only have one, and you just affect by one razor, and if you have more number of the aluminum foils, maybe you will affect by razor 1 and razor 2 in the same time.
So do you mean that it will be remaining at the highest speed if you put more strips of aluminum foil onto your rotor?
You will have more chance to get more force in the same time because the number of foil is.
Okay. Another point is that have you ever thought of putting more electrodes on your rotor? Like razor 1 is a electrode, razor 2 is also electrode. Have you thinking to put more razors onto your electrode, onto your rotor?
Oh yes, but if they have a lot of size in the because too many razor will make the duration of the rotor it would be thin because the force is come from different side in the same time. So maybe we resistant each other and make the rotor would not spin.
But according to the theory of the ionic wind, if you change your razor 1 and razor 2, either of them to positive and negative electrode, and not one connected to ground, one connected to positive electrode, if you change them into one is positive, one is negative, then they will form a ionic wind. And if you put more electrodes on your rotor, the ionic wind will be stronger because it will be one pushing it and one attracting it, and it will be like putting more force onto the ionic winds, and it will hit the rotor and make the rotor roll.
Because if the part is more foil and the force it will make a rotor hard to spin because the charge is on the too many charge on the foil.
Okay, let me read a passage right here. This is about the ionic wind. And when a strong electric field is generated near of the electrodes to form a coronal discharge of air at electrodes tips, the air motion is created by the coronal ions generated at the electrode, which drift either to the grounded rotor or to nearby surrounding electrodes. And along their path, these ions collide with the electrically neutral air and transferring their momentum into air molecules and resulting in the so-called electric or ionic wind. And so my suggestion here is not what I'm talking about here is not the rotor that you make, because it's two of them is different. Yours is one connected to positive electrode and the other one is connected to ground. But now what I'm talking about is the rotor the motor that forms a electric or ionic wind, which is one electrode is connected to positive electrode and the other one is connected to negative electrode. So the air motion will be from positive and be rejected to the negative. And so it turns like clockwise.
If this is a positive and this connected negative, and maybe it would be too high and cause the spark and will let the rotor hard to spin.
But that is why you have to tilt the razors, because if you don't tilt the razors, the direction of your ionic wind will not be constant, so it will interfere each other and make it weaker. It will attenuate your ionic wind. But if you tilt your razors at the same direction, it will turn the same side.
You may don't tilt the razors.
No, I mean you have to tilt the razors. If you tilt the razors, both between electrodes there won't be sparks happening, because this rotor is based on coronal discharge, and coronal discharge only happens when you're at sharp points, and the sharp out sparks like lightning. But if you didn't get the points too close, it will not form. They will not form the spark.
But
Yeah.
if there's a force of plus and the side of negative and have some force, not just like we want. And if we only connected the negative side.
Okay, so sorry. I want to make a final closure now. Is that your experiments, you didn't mention how to maximize your speed and to optimize your rotor, and I think that's just the main point of this experiment. And you didn't do that in your conclusion.
I just compare the parameter and choose the best parameter, and I think that is to get a maximum speed.
We just end the discussion here, and you have 1 minute to summarize.
Oh. Okay, so I think is that, of course they've done experiments, but I think they did not outline the most important parameters, and they did not reach the goal of how to optimize their rotor. And I think there's a lot of designs for the rotor, and my suggestion is that I think maybe they can try different designs for their motor, such as putting more electrodes, or use another electrode with a positive and a negative electrode, and not this one with a grounded with the grounded wire and the positive electrode. Thank you.
Thanks for the reporter and the opponent. I have a few questions for the reporter. Do you think there will be any other energy loss during the rotor rotating?
balloon because it rotate very fast. Just a little.
To the opponent, do you think there will be any energy lost in the rotating?
Yes, of course, because the center is a stick-like thing that is holding it, and there will be friction inside, but it will be very small. We can ignore it, but there's obviously there will be a little friction.
Thank you. And the professor say that you have to optimize your design. And according to your presentation, could you tell us where is the optimization?
I think I should use not so many.
You only discuss the parameters during your experiment, and where is the optimization of the rotor?
To find the maximum speed, and I think I change the number of foil and angle of the razor, and the system finding value is also a factor to reach the maximum speed.
Okay, then to the rotor. And what do you think is the main factor causing the rotor to rotate?
I think is the angle of the rotor, because if the angle is almost line into the center, the rotor won't spin.
Okay, then to the opponent, what do you think is the main factor for the rotor to rotate?
Oh, because I already said, on razor 1, which is connected to positive electrode, will form very strong electric field and ionizes the air molecules around it. And when the air molecules hits the aluminum foil on the rotor, the aluminum foil will be also charged positively. And so same electrodes, they will reject each other. And so the razor 1 will push the rotor, and the rotor will roll to the other side. And when it is rolled to the other side, razor 2 is connected to ground, and it will put the electrons back into the aluminum foil, and so it will be neutralized and turn back again and do the same process. And so I think the main point is the Coulomb proportion.
here, and today I'm reviewing the question number 1. Invent yourself. First of all, the problem statement told us that we had to build a simple motor whose propulsion is based on a corona discharge, and resting on the motor's motion depends on relevant parameters and the optimization to a maximum speed and the fixed out input. And this is the reporter's outline. First, she gave us an observation picture, but there's no photos. The video did not show, so we didn't know what exactly the rotor is changing. And the theory is that she talked about the corona discharge and the Coulomb's law, and she did good on. She gave us a clear schematic diagram, and in the experiment part, she told about angular velocity versus the foil changes the angular velocity and the angle of the resistance, but she's lack of parameters. And the discussion, it should be optimization during his including her presentation, but there's no optimization in it. So that I think this is the part she could improve. And finally, she gave us the conclusion that the foil, the angle and the resistance increase as the angular velocity increases. And during her presentation, the most important is the optimization part, but she did not mention it. She just kept talking about the parameters she changes, including the experiment. And this is the opponent pros and cons. And the opponent's pros is that he figured out the weakness of the reporter, and he gave a clear clarification of the parameters, since that he asked a lot of questions about the parameters the reporter had talked about. And the cons of the opponent is that he's a little bit out of the time controlling of him could be improved, and he did not explain the reason of asking each question, which the reviewer thinks is the most important part among the opponent's job. And he didn't talk about the optimization, such as that the problem statement had required. On the discussion is that the opponent asked about what about putting more electrode on the rotor, and the reporter answered that first the force will come from different sides and started from spinning. But I disagree with the reporter, since that I think if there are more electrodes, the angular velocity will increase. And next, come to the reader's question and answer. I asked about do you think there will be any energy loss during the rotor rotating? The reporter answered that it won't. It's just a little bit of that. But I think I agree with the opponent that the friction between the axis and the rotor will influence about the rotor rotating, and that could be. And that could be included in the optimization part. And what is the main factor causing the rotor to rotate? And the point is that the reporter missed about the optimization, which the problem statement required. And my conclusion is that there will be energy loss, and it should be more parameters we talked about. Thank you.
Next, illustration of I consider in the competition maybe the opponent could more focus on my experiment, and but just keep stick on making the comparison to the experiment with his, and so I consider that kind of behavior is not appropriate, and because I think the discussion should be based on my experiment result and not the opponent's own opinion. And record an index of parameters, but which maybe I don't know what is enough, and I afraid that a reviewer didn't focus on my report and my presentation, and in addition, I think the optimize is to find a maximum speed, and I change some factor to find the maximum speed. And thanks for the tutorial.
Okay, now we have time for Q&A. Question?
I have a question for reviewer. So what's your opinion on the optimization? So what do you think the most important part lead to the optimization?
I think the optimization could be that the more electron put around the rotor, the input voltage, if the input voltage is higher, the rotor might rotate faster, and the number of the and the sharpened size of the aluminum foil, the electron.
Would you like to say something, opponent? Say something about optimization.
Okay, so what we had done in our experiments, and can I talk about our own experiment?
Just general point.
Okay, so what we've done is that we found more, yes indeed, more electrodes can optimize the rotor, because at same voltage input, the rotor can grow faster, and also the air gap between the electrodes and the rotor, if it's smaller, the Coulomb repulsion between the electrode and the aluminum foils on the rotor will be bigger. So both of these aspects will make the rotor roll faster.
Okay.
Any more questions? Okay. Now we conclude this one. Seven, five. Six, eight, seven, eight, seven. Eight, 9, 7.
Thank you.